This is brought to you by the Alumni Association of PISJ-ES.
We will be doing some more examples today regarding velocity time graphs and the position time graphs, or the displacement time graphs and the acceleration time graphs. So first of all, let's look at an example here. Here we have a position and time graph. So remember that this is a displacement time graph. I can call it a displacement time graph, okay, because the unit is in meters. Let's see the first question. Just look at the graph. You can see that since this is a displacement time graph, the question says the position time graph below represents the motion of South's basketball coach during the last 16 seconds of something here during this past weekend's game. Okay, so this is the initial point, the point 0. You should have an intuition of this first, the point 0. In 4 seconds, he then moves a distance of 8, and till this point here, he's standing still since the distance is not changing from the origin. And always remember, we are always talking about the origin. Then he comes back to the position 4, fourth mark, as in 4 meters away from the origin. Then he stands there still for a while, then goes back again 8 meters from origin, and then finally comes back to the origin. That is what's happening. So now the question says, determine the total distance walked by the coach during these 16 seconds. So the total distance walked by the coach during these 16 seconds. So let's see, it's a position time graph, so we can just simply take the distance by the corresponding values. So we know from time 0 to 4 he travels a distance, and since in distance the direction is not of importance, so we'll just simply be adding up the distances that he moved. Okay, the length he covered. So from 0 to 4 he moved a distance of 8 meters first. Then from 4 to, let's say, 6, 4 to, let's say, 6, he just stood still and didn't move any distance. So this is 8 meters and this is 0 meters. Then from 6 to 8, he came from the 8th mark, from 8 meters away, to 4 meters. So he again moved 4 meters. We know that he might have come closer to the origin position, and he might be running as in moving in reverse, but the direction is not important since the question asks distance. So the direction is not of importance. We'll just be adding up the lengths that he covered. So again he moved 4 meters from 6 to 8. From 8 to 10, let's say, he moved 0 meters since he was there at 4. From 10 to, let's say, 14, time 10 to time 14, he moved from the 4th position to 8th position back again. This makes it again 4 meters. And then finally from 14 to time 16, he moved back here and covered 8 meters back to the origin point. So the direction is not of importance, remember, because the question asks specifically distance. Now since it's the total distance, so we will just add all the distances. It could be 8 plus 4 plus 4 plus 8. And if you want to add the zeros, it would just be stupid to add the zeros. So I'm not adding the zeros here because they don't have any value. So 8 plus 4, 12, 12 plus 4, 16, 16 plus 8, 24 meters. The coach walked 24 meters during these 16 seconds. The distance was 24 meters. Let's talk about the displacement. Let me just clear it up a little here. Okay. Now it says determine the resulting displacement of the coach during these 16 seconds. Now if you remember, what we do is we see the original position of the coach. He was at 0, and after 16 seconds he was back again at 0. So he might have taken a path like this, but after the 16 seconds he was back at the same point. So actually we can say that since he was back again and he by the 16 seconds he hadn't covered any distance from 0, although he any displacement from 0, because he's still at the same point. So we will say the displacement is 0 meters. Also, you can check that way. We found out that this was 8 meters in these 4 seconds. Then he stood here. Then he covered 4 meters. But now, since it's displacement, the sign is important. So since he's coming back, we'd call this minus 4 meters, covering minus 4 meters. Then he moved another 4 meters, which is, since he's going far away, so we just take it positive. So we are coming near to the point as negative and going far as positive. So after this point he's coming close to the origin and covered 8 meters. So this would be negative 8 meters. Now just add all of these. So this would be 8 minus 4 plus 4 and minus 8. So this would again give you 0. So the displacement is 0 because he was in his final time, at time t is equal to 16, he was at the same point where he was originally. So the displacement is 0. I told you earlier as well, it doesn't matter how much distance he has covered. The displacement is regardless of the fact that he has covered a distance of 24 meters, the displacement only looks at the original position and the final position and the distance between the two of them. That is what displacement is about. Let's go to part number C. Determine the displacement of the coach after 12 seconds. So this is 12 seconds. So this is 12 seconds here. I think you can't see. So let me just change the color of the chalk. We just see where his position is. So he is approximately at 6 meters, or I think 5.5 meters or something. But let's just say he's at 6 meters right now. Okay, he's at 6 meters at 12. So if you want to calculate it, you can. However, you know that we can also calculate it by looking at the original and the final positions. So let's do it that way first. The original position is 0. The final position from 0 is 6 meters. Irrespective of the fact that he has moved this way and that, the final position is 6 meters away from 0. So I can simply write displacement is 6 meters away from 0, from origin. You always have to specify the direction. However, if you want to do it numerically, let's do it numerically. This is, since it's going away, so we have decided that away would be positive. So this is a displacement of plus 8 meters. This is a distance of 4 meters closer to the origin. So this is minus 4 meters. And this again is a displacement away from the origin. It's going farther. So, and from 4 to 6. So this is 2 meters, positive 2 meters. So let's just add these three up. So you'll see 8 minus 4 plus 2. Again, you will get 6 meters. So that is how you find out the displacement. Let's see another part here. At what time did the coach have the greatest displacement from his starting point? At what time the coach had the greatest displacement from his starting point? So we know that when he's farthest from point O, that is when he has the greatest displacement. Let's see, when is it when he's farthest from O? There are 2 points here. At this point, he is at 8 meters from O. So his displacement becomes 8 meters here, positive 8 meters. And even at this point, he is at 8 meters. So again, his displacement is 8 meters at these 2 points. On the other points, his displacement would simply be, for example, at this point, his displacement is 6 meters from O. At this point, his displacement is 6 meters from O. At just simply this point, his displacement is 4 meters from O. At, let's say, this point, his displacement is 2 meters from O. So these are the distances, these are the times when he covered the maximum displacement from O. So one is 4 seconds. At 4 seconds, he covered the maximum displacement. And the second would be 12, 13, 14 seconds. So there are 2 times when he covered a displacement of 8 meters. Alright, so now we are done with displacement and distance.